All right, in this video we're going to do an exercise in logic. The exercise is based on a puzzle called Mini Sudoku. So Mini Sudoku is a smaller version of the popular puzzle game. It's played on a 4x4 instead of a 9x9 board. In Mini Sudoku, we try to fill in the digits 1 through 4 into each cell of a grid using the following rules. Each digit has to appear exactly once in every row, exactly once in every column, and exactly once in each of the 4 bold outlined squares of the grid. So, for example, it has to appear exactly once in this region here. So in order to solve a mini Sudoku puzzle, we can solve it in our heads, and then we can also solve it using the rules of propositional logic. And it's really important to be able to take a real-world problem like this, well, sort of real-world, and model it using propositional logic, and then use the rules, the inference rules of propositional logic to solve it. So let's do it first, solving it in our heads. Let's say our goal is to fill in just this bottom right quadrant, the cells labeled A, B, C, and D. So we can first notice that because of this digit 3 here, 3 can't be in cell B or D. And because of this 3 here, 3 can't be in cell A or B. So that means there's only one place left for the 3, and it goes here. Similarly, because of the 2 right here, 2 can't be in cell B or D, and so it has to be in cell A or C, but C is already full, so we have to put it in cell A. Now the 1 says that you can't have a 1 in cell C or D, and because the cell A is already filled with a 2, we have to put the 1 in cell B. And then finally there's only one option left for the 4, and that's to put it in cell D. So that's how to solve it sort of informally in our heads. What we're going to do now is try and write down how to model this problem using propositional logic and solve it in that format. So in order to do that, we have to write down all of the constraints that we know about. So let's first write down constraints that come from these fixed numbers that are in the adjacent grid cells. So because this 3 is here, we know that a 3 can't be in cell B or cell D. And I'm going to write that as 3 sub B means that the digit 3 is in cell B, and so we know that it is not the case that the 3 is in cell B, and we also know that it's not the case that the 3 is in cell D. And what I'm going to do is I'm going to write each one of our constraints as a logical clause. A clause is basically an expression of the form A or B or not C or D and so forth, where you only use or as a connective, and the arguments to or are either variables or negated variables. So this is a very simple clause where there's only one variable, 3b, and it's negated. We're going to get some more complicated clauses later. All right, so similarly, because of this 2 right here, we know that 2 is not in cell B, and we know that 2 is not in cell D. Similarly, we know that 3 is not in cell A, and we know that 1 is not in cell C, and it is also not in cell D. And that's what we know from all of the fixed digits here. Now we have to write down the rules of the game, right? So the rules of the game, for example, include that the digit 1 has to appear in one of the cells A, B, C, or D. So that's easy to write. 1 is in cell A, or 1 is in cell B, or 1 is in cell C, or 1 is in cell D, right? And we also know that the 1 has to appear in at most one of those cells. We can't write that as a single clause, but it's easy to write it as a bunch of clauses together. So the way we're going to do that is to say that if we pick any 2 cells, let's say A or B, so 1A and 1B, right, it has to be the case either that 1 is not in A or that 1 is not in B, right? And the reason for that is this is basically saying that 1 can't be in both cells A and B, right? And then the same thing holds for every other of the 4 choose 2 possible sets of cells. So we have, for example, either 1 is not in A or 1 is not in C, right, all the way down to 1 is not in C or 1 is not in D, right? And so these 7 constraints right here say that 1 has to appear in at least one spot and at most one spot, and so together exactly 1. And then we duplicate all of those constraints for 2, 3, and 4. So similarly, there's a rule that says that there's a rule that says that 1A or 2A or 3A or 4A, right? That says that one of the digits, 1, 2, 3, or 4, has to appear in A. And then, just as before, at most one of those has to appear. And so we have 6 constraints here saying either 1 is not in A or 2 is not in A, right? Both 1 and 2 can't be in A, all the way down to not 3A or not 4A. All right? And so now, and again, we repeat that now for A, B, C, and D, right? So there's a set of 7 constraints for cell A, another one for cell B, another one for cell C, another one for cell D. And now, given all of this information, we can try and formalize the intuition that we used before. So for example, this 3 that appears in cell C, we had assumptions that said that, or sorry, not assumptions, we had information from the problem, which we treat logically as assumptions, that said that A was not in cell, that 3 was not in cell A, right, and also not in cell not in cell B or cell D, right? And so what we're going to do is we're going to combine these 3 bits of information with the constraint for the digit 3 of this form, right? So that constraint looks like 3A or 3B or 3C or 3D. And for example, if we take this guy here, not 3A and 3A, so we have 2 clauses now, one with 3A positive and one with 3A negative, and we can use resolution to conclude from those 2, right, that we have 3B or 3C or 3D. Similarly, from this guy, right, we can get rid of 3D and get 3B or 3C, and from this guy we can get just 3C, right? And now we're done showing that 3 has to be in space C. Now similarly for 2, right, we know that 2 has to be somewhere, so that's 2A or 2B or 2C or 2D. And we have these guys right here that show us that it's not in B or D, so by resolution we can conclude 2A or 2C. And now, because we just concluded 3C, right, we know one of the constraints is not 2C or not 3C, right? And so if we do resolution from those guys, we get not 2C. And now we can do resolution from those two guys and get that 2 must be in cell A, right? And so we can fill in that 2 right there. And we can keep on going. I'm not going to finish this exercise here, but you can see that using resolution on the clauses that we've written as constraints for our problem, we can pretty easily fill in the 1 and then the 4.